Hey everyone, how you doing? Can't make it in today, but I'm feeling good. Need to give you some notes here. So we're going to start looking here at chapter 4 right away. We'll take a look at this book thing right here. This is the first page in there. These are your sections. We're going to talk quick translations, reflections, rotations, and dilations a little bit. Congruence and transformation. You're going to see some of that in here in a second. And similarity and transformation. Similarity for 1, 2, and 3 are all congruent, which is, if they're congruent, it's similar. 4.5 results in similarity. I'll show you when it's not similar, too. The little pictures on here are just giving ideas. The zoom in of a magnification. That's a dilation, like when I zoom in on that zoom in picture, like you do with your pictures on your phone. That's dilations. Those are dilations. Kaleidoscope here, this has some rotational symmetry in it, as does, so that's the kaleidoscope, as does the revolving door, has a rotation in it. The chess pieces, those move like a translation. You can describe how they move in X and Y directions. So let's get on with it. We're going to relate to these in a minute. So I'm just going to show you some quick examples of what these look like so you can get a feel for them. We'll get into rules later. There are some specific rules we use on the coordinate plane. That's your XY coordinates. But we'll start off with the translation here. So we're starting off with the translation. Or sometimes it's called a glide reflection. That's just sliding it across the plane. You're just moving the shape. I'm taking it, I'm moving it over here. I moved it back. Notice the shape size doesn't change. I moved it over. Left, right, up, down, combinations of those. So you know I can move it. I can move it left. I can move it up. It doesn't have to totally clear the shape. I can move it right. I can move it down. It can totally get off the shape. But that's a translation. Okay? Trying to think of an example of this. If I ask you to move your desk up, that's a translation. I ask you to move your desk to the side, that's a translation at school. Next, we've got a reflection here, which I already underlined. Think of this as flipped across a line. In fact, when I do this with my computer, you'll see it says flipped on there. It's also called you can think of it as a mirror reflection, because like a mirror, everything gets turned around on there. Now, when we're doing these, we're reflecting it across a line, like this one, the y equals k line, or x equals k. That's a vertical line. We'll talk more about that later. You should remember that from algebra. Y equals k, that's something else from algebra. K is just a variable here. We usually use the x-axis and the y-axis. But visually it can be anywhere. And then later we do these ones over here. The y equals x, the y equals negative x. We'll talk more about those later. Now, I'm going to click on one of these shapes. I'm not sure which one it grabs. I'm going to rotate it. Now, like I said, it's got to go across one of these lines. And I'll show you in a second here. I'll just do it. Okay, it says rotate there, but it says I'm going to flip this one horizontally so you can turn it around. Now, this initial flip here is like it was going around this line right there. It flipped it right around that line. That's a little harder to see. I'm going to take that and come on. There we go. And I move it down here, right about there, and we got it. Now, that's flipped across this y equals k line here. You'll notice these points equidistance from that line. These points are equidistant. These points, the vertices, I should say, are equidistant. These points, these vertices and the line are equidistant. That's one of the trademarks of a reflection. Okay, let's move some of this back. So I move my diagram back here. I can also flip it horizontally, or again do a reflection. Again, this is like I had a little line running through it right there. It's flipping around that. A little easier to see what's happening if I just slide it over here a little. Whoops, I grabbed the wrong one. No, I didn't. That one will work. Doesn't matter which one I grab. Okay, there we go. And again, you can see that equidistant bit I was talking about right there for the vertices on there, reflected around that line, the vertical line right there. Again, we can do them over here. A little harder to draw those. I don't have something built into the program to do it. We got some formulas to do that with later, so that's not as big of a deal to do those. And you get to use those formulas. You don't have to memorize them. You have to know how to use them. Pretty magical how that shape just got back there, isn't it? I got to remember to make this bigger. Okay. Rotation. You can show this on your phone too. I guess I can't do a real good phone example for that, but I could show it on my phone at school a little bit easier. So this rotation is turned around a point frequently. So it's kind of like pinwheeling around a point, like the axis on the revolving door that they showed earlier, the center of the pinwheel. I'm going to end up using this point for my rotation. And again, I'm going to choose one of these shapes. I don't know which one it's going to pick here. And I'm going to rotate this. I'm going to go, they call it right, better to know clockwise and counterclockwise. To the right is clockwise. So I move it up like that. And I would have to pin that point to it right there. And there's my shape going that way. And I've rotated this 90 degrees now. Basically, this point is just turned around like this. This point is just turned around like this. And this point is turned up that way. Okay. It's interesting. 1, 2. I need to shoot. My pause button disappeared. That doesn't make me happy. I hate it when that happens. Okay. Put that back. Actually, let's get that there. I could do this again. Another 90 degrees. I've got to get my point to line up right there. That's gone 180 degrees. I could get it to rotate again. Line up that point that's supposed to be pinned down. That's 270 degrees. And if I go another 90 degrees, it'll be right back on top of itself again. Back where we started. Okay. Dilation. Sorry, I can't use my pause button anymore because I don't know where it is. Let's see, this isn't working the way I want it to. I paused at some point. I got this thing working again, but we'll see what happens here. So dilations, you do this on your phone all the time. You already did it. You zoom in on something, zoom out, that's a dilation. Now, enlargement or reduction. Whoops, went a little far. And then we have the one I already had underlined, proportional. It's got to stay proportional. That's the key. That's what you're going to be doing in the assignment. So, dilation, it's with respect to a point. This time I was doing it with respect to, whoops, this point right here. This time I'll do it with respect to this point here, you'll notice. This just means it's going around that point. So we get it in there. Now to do this on computer, notice I'm going on this diagonal right here. This is not a dilation. That's not a dilation because the sides aren't similar anymore. This isn't a dilation when it goes down like that. That's not a dilation. Everything has to change proportionally. Okay? And then we have compositions combining two or more of these. One, I did a translation. Now I have done a, whoops, it didn't go. Let's do a reflection, and it's not, you can't see that one. That's why that's a bad one to choose there. Okay, rotate, flip vertically. There we can see it. And then I could do a dilation, and that's a composition, putting all those things together. So let's look at the work from page 171. Not a lot of problems to do here. So again, first, translation, reflection, rotation, or dilation. So pick that out from what I showed you before. They're explaining this one right here. I just gave you some examples. You're doing it right there. These are some more examples here. They're saying that the blue figure turns to the red figure is a rotation. That's a mirror image. Now this one, notice they're using fractions on it. So they're A to B. That's rectangle A to B. Corresponding sides, long to long, short to short. 8 to 4 reduces to 2. 4 to 1 reduces to 4. Those aren't the same number. It's not proportional. So that is not similar. Now, if I check this one over here, the 8 to 4 went to 2. Here I have long side to long side, 8 to 6, which goes to 4 to 3. Then they do short side to short side. Oh, that's also 4 to 3. That's the same. They're in proportion. So you get to do that down here with these. So again, it's going to help you to think here. I need to change this background. Go long side to short side. Think about this. So I'm going to go 12 to 14. Is that going to be equal to, the other one would be 5 to 7. I'm going to just put that over here. 12 to 14, I can reduce that, divided by 2, divided by 2. That gives me 6 to 7. Are those equal? Does that mean they're similar or not similar? Can't remember. What did this example tell us back here? Just take a look at those. So you'll have to do that. This one, you got to do all three sides right there. Got to do all three sides to make sure it works. All three have to be in proportion too. And that's it. A little longer than I wanted. I still finished a little bit early here. Take care. Have a good day. Get some work done. You guys can do it.